Hello, my brilliant students. I hope your exam prep is going full on Josh is high. Today, we're going to tackle a chapter that sometimes, it looks a little bit intimidating, redox reactions. But please don't worry. I promise you, by the end of our little session today, you'll see it's actually one of the most logical and, yes, high-scoring topics in your entire syllabus. So trust me on this one, okay? This whole chapter, it's really all about understanding just one simple, single idea. Once that clicks in your head, poof! Everything else just falls into place, like magic. So let's just clear our minds, take a deep breath, and get ready to absolutely master this. Let's get started. So here's our game plan. First up, what exactly is redox? Then we'll look at the old school definition and the new modern one. After that, we unlock the secret weapon of this chapter, the oxidation number. Then we'll check out the different types of reactions and finish with the big one, that balancing act. It's going to be a clear step-by-step journey. All right, let's jump right into the most fundamental rule of this chapter. The word redox itself is a clue. You see, it's two words smashed together, reduction and oxidation. And the thing is, they are a package deal. They always happen together. Just think of them like Jai and Viru from Sholay, totally inseparable. You simply cannot have one without the other. It's impossible. If one atom is losing something, another atom absolutely must be gaining it. This, my friends, is the golden rule of all redox reactions. Remember this. Okay, so let's rewind a bit. Let's go back in time to see how scientists first tried to explain these reactions. This is what we call the classical, or the old school definition. It's a really simple starting point, and it only focuses on two key elements, oxygen and hydrogen. And honestly, it's very straightforward. The old idea says that oxidation is when you either add oxygen or you take away hydrogen. And reduction, well, it's the exact opposite. You either take away oxygen or you add hydrogen. See? Simple enough, right? Let's look at a classic example. You've all seen a magnesium ribbon burn with that bright light, no? When magnesium combines with oxygen, it forms magnesium oxide. Now, because oxygen was added to the magnesium, we say that the magnesium has been oxidized. Easy peasy. But science is always growing, always leveling up. That classical definition was a good start, but it couldn't explain every single reaction. So chemists came up with a much more powerful modern definition. And this one focuses on the real hero of all chemistry, the electron. Okay, now here is a trick that you will never ever forget. Just remember this. Leo, the lion, says Gur. LEO stands for loss of electrons is oxidation, and GER stands for gain of electrons is reduction. Simple. But here's a little twist. The substance that gets oxidized, the one that loses electrons, is called the reducing agent. And the one that gets reduced, that gains electrons, is called the oxidizing agent. It's the opposite. A little confusing, I know, but you'll get it. Let's see this happen in a real reaction. Making our everyday table salt sodium chloride. Sodium, or Na, it gives away one electron, so it loses an electron. What is that? That's LEO, oxidation. And chlorine, Cl, it eagerly grabs that electron, so it gains an electron. And that's GER, reduction. See? It all makes perfect sense now, doesn't it? All right, champs, get ready. We're now moving to the ultimate tool in this chapter. Seriously, if you can master this one concept, you can solve any redox problem that your exam paper throws at you. It is the master key. It is the oxidation number. So what is this thing exactly? Well, you can think of it like a score. We assign the score to each atom just to keep track of where the electrons are moving. It's like an accounting system for electrons. So if an atom's oxidation number goes up, it has been oxidized. And if its number goes down, it's been reduced. Simple. Now, to give out these scores, we just have to follow a few simple rules. Okay, pay very close attention here. This slide is super important. Maybe even take a quick screenshot for your notes. So any element all by itself, like O2 or just Na, its oxidation number is 0. For a simple ion, it's just its charge. Oxygen is almost always -2, and hydrogen is usually +1. And the most useful rule of all, in a neutral molecule, all the oxidation numbers have to add up to 0. Okay, time to put these new rules to work. Here's a quick challenge for you. What's the oxidation number of sulfur in the sulfate ion, SO4 with a 2- charge? Go on, pause right here, grab a pen, and use the rules we just learned. Give it a shot. Okay, are you ready for the answer? Let's solve it together, step by step. We don't know sulfur's number, so let's call it X. We have 4 oxygens, and we know each one is -2, and the total charge of the whole thing is -2. So our equation is x plus 4 times -2 equals -2. A little bit of simple maths, and boom, x equals +6. If you got that right, fantastic job. You are already becoming a pro at this. Great work, everyone. Now that we have our master key, the oxidation number, we can start putting these reactions into different categories. For your exams, you really only need to know about these 4 main types. So just make a mental note of these 4. There's combination, where 2 things join together to become one. Then there's decomposition, where one thing breaks apart. Then we have displacement, which is kind of like a chemical survival of the fittest. And finally, the really interesting one, disproportionation, where one element is getting oxidized and reduced at the same time.
Now, let's take a closer look at displacement with this classic lab experiment. When you put a zinc rod into that blue copper sulfate solution, something amazing happens. The zinc, well, you could say it's the dabang element here, it's more reactive, so it just kicks the copper out of the solution and takes its place. That's why you see that reddish copper depositing on the rod, and the blue color of the solution starts to fade. It's a pure power play between metals.
Okay, team, we have reached the final level, the final boss of this chapter, balancing redox reactions. This is very often a 5-mark question in your board exams, and I know it can look very intimidating, but I promise you it's just a puzzle, and it has a fixed set of rules. We are going to conquer it together.
So, the most common way to do this is the half reaction method. And these steps, they're like a recipe for a perfect dish. You just follow them in order and you'll always get the right answer. Step 1, split the reaction into 2 halves. Step 2, balance all the atoms that are not oxygen or hydrogen. Step 3, balance the oxygens by adding water, H2O. Step 4, balance the hydrogens by adding H+ ions. Step 5, balance the charge by adding electrons. And the final step, 6, make the number of electrons in both halves equal and just add them up.
Now, look at this. This is a very typical exam question. It looks so complex, right? But if you just apply those 6 steps one by one, you will arrive at this final, perfectly balanced equation. See how we've added H+ ions and H2O molecules to make it all work? That came from following the steps. The secret here is just practice. After this, try 2 or 3 examples from your textbook and you will become a balancing champion. I guarantee it. And we did it. You guys did an amazing job. So let's do a super fast recap. What is redox? Oxidation and reduction happening together. The magic trick? Leo the lion says jur. Your superpower? The oxidation number. If it goes up, it's oxidation. If it goes down, it's reduction. And don't forget the 4 main types of reactions we discussed. So now that you're all redox experts, here's a little something for you to think about. We know that burning anything, a candle, fuel in a car, that's a redox reaction. But can you think of another one? One that's happening all around us, maybe even inside our own bodies, right this very second. Huh? Just think about it. And that is a wrap on redox reactions. See? Not so scary after all, was it? You now have all the tools you need to completely master this chapter. Keep practicing, stay confident, and you are going to do absolutely brilliantly in your exams. All the very best, my dear students. I know you will make me proud.